I don't know if it's recording. How do I know? Oh, it is recording. Okay, guys, it's recording. In Jesus' name. Okay, so today I have not, this is Amy Killmon at Calvary Christian School. Dahana and Seth are going to be my helpers today.
Today is Friday.
Oh, yeah. Thank you. Today is Friday, January 19th. I think it's Sister Barbara's birthday. I think. Anyway, and we are working on Chapter 7, Section 1. We've already got a little bit into it, but we're starting with the activity reaching for chips. So we're going to kind of do a little bit of this with Dahana and Seth. They're going to help me just so it can kind of be clear to you about what we're talking about into the lesson. I think it will be, but let's go ahead. Now, we are going to, this is for a population of 200 colored chips. And Seth, can you hand me those so I can put them under the screen? They can see them. Okay, so here's our 200 chips right here. Now, 100 of them are red, and 100 of them are not red, okay? So this is the activity we're going to be using it with. The parameter is the actual proportion of P red chips in the population. So P equals 1/2. In this activity, you will investigate sampling variability by taking repeated random samples of size 20 from the population. You two go ahead. You take a sample of size 20, Seth, and count how many are red. Put your sample back in, mix it up, and then Dahana does it, okay? Now, you really need to do it. If you can do it quickly, it would be best. Okay, after your teacher has mixed up the chips thoroughly, each student in the class should take a sample of 20 chips and note the sample proportion P hat. So that's the proportion for the sample. That's why it has the little hat. I'm going to see if I can get that a little clearer. Okay, let me zoom in just a shade. I feel like we're too far out. Okay, focusing again. Okay, of red chips. When finished, the student should return all the chips in the bag, stir them up, and pass the bag to the next student. We have a little glass bowl, or plastic bowl, not a bag, but at any rate. So Seth's done one sample, and he is passing that on to Dahana to take her turn. You can hear them mixing in the background. I might let you see them momentarily. Okay. So then, and we obviously today especially have lower than 25 students. We have 2 because of the tournament. Then we'll have to do several. That's why we're only kind of going to do partially this activity just to see what's going on. Now, each student should record the P hat value in a chart on the board and plot this value on the class dot plot. Label the graph scale from 0.1 to 0.9 with tick marks spaced at 0.05 units apart. Okay, now, so let's see if we can see Seth. I'm going to turn this very carefully. Are we there yet? Oh, he's upside down, sort of. Okay, let me see if I can turn this. He's sideways. Okay, so he's sideways. So Seth, how many red did you get out of that sample?
I got 8 out of 20 red.
8 out of 20. Okay, so what proportion is that? Point what?
Like 0.4?
Mm-hmm. Yep. Okay, so Dahana, we're moving around to her. I know she's still sideways. Do you know how many? What was yours?
13.
13 out of 20. Do you know what your proportion is? Do you have a calculator? Oh, okay. Well, I'll do it real quick on my phone. So, 13 divided by 20, 0.65. Okay? Now, what is our expected value? Dahana or Seth? 0.5. Yes, it is. Okay, we're going to go back down here. I'm going to make everybody dizzy. Okay. All right, so the expected value was 0.5. Now, did either one of them get 0.5? 9. No, they didn't. Okay. However, if we did this many times is the question. right? What do you think would happen?
Would even out to about 0.5.
Okay, so over the long haul, the long run, right? Okay, so I would love to continue this, but we really don't have time, and it would take a long time for them to do enough, like both of them to do 15 or something. It would take a while. So we're going to go on and talk about it. And they have talked about Mr. Caldwell's class that actually did this activity, Reaching for Chips activity. His students produced the graph shown in figure 7.1. And that is right here in the screen. Here's what the class said about its distribution of p-hat values. Now, so this is the distribution of the p-hat values for Mr. Caldwell's class. So they had, apparently that's 25, and the highest one was 0.7, which was close to, Dahana's wasn't far off from that. Hers was 0.5, where those 4 dots are, and Seth's was at 4, or 0.4, so over here. And so many of them were done. Now, let's talk about this. The shape of this graph is roughly symmetric with a single peak at 0.5. Do you guys agree? Mm-hmm. Roughly symmetric single peak. The center, the mean of our sample proportion is 0.499. That's very close to 0.5. So if you have done your reading, is this biased or unbiased? Do you feel?
Is it unbiased?
It's unbiased because the actual proportion of 0.5, which we know is true, is very close to 0.499. Those are very close together. So that's unbiased, okay? We'll get to that in a little bit. Sorry, getting ahead of myself. This is a balance point of the distribution, right? Where it would be like you put it on a teeter-totter. Now, the spread or standard deviation of our sample proportion is 0.112 on average, and you could figure that out with getting all those numbers together and finding the standard deviation. On average, the values of p-hat are about 0.112 away from the mean. On average, the standard deviation is 0.112. And then you move out 2 standard deviations, you'd multiply those by 2, and 3 would go out to here. Now, it looks like, you might look at that and think that's an outlier, but if you did the test for outliers, which would be 1.5 times the interquartile range, this would not be an outlier. So there are no obvious outliers on the usual features. Okay, now, how many different ways could we pull out a set of 20 of those chips and get all of the possible ways? It's a lot, folks. And they tell us right here in the reading. About 1.6 times 10 to the 27th. That's a humongous number. Do you think we have time to do that today? Yeah. The answer would be absolutely not. Okay. Or even in a lifetime. I don't want to do that either. It'd be very boring. Okay. But if we could get all of them, then that would, and we would put them on a dot plot, that would be what's called a sampling distribution, meaning we took all possible samples. So let's read this. Sampling distribution of a statistic is the distribution of values taken by the statistic in all possible samples of the same size from the same population. Okay. Now, I just don't want to miss anything that we're supposed to be talking about, but this next example is more about that same activity. So we want to talk about that a little bit more. Let me see if, I don't know if I can get all of that in here right now. Okay, so simulating a sampling distribution. So this is a simulation of one. We used Fathom software to simulate choosing 500 simple random samples, so that's quite a few. It's not all, obviously, of the size 20 from a population of 200 chips, 100 red and 100, in our case, not red, but in their case, blue. Figure 7.2 is a dot plot of the values of p-hat. So we have this right here. And now it almost looks like straight lines, but if you look in your book as you're listening to this activity or sitting in the classroom, you'll see those are tiny dots, and there's just so many it almost looks like a line. Okay, is this the sampling distribution of p-hat? meaning all possible outcomes. No, it's simulating the sampling distribution, right? But it's not the actual sampling distribution, because the actual one would have, I don't even remember what that number's called. 10 to the 27th power. I mean, that's really huge, and I have to really think about that. Okay, so it doesn't have all of them, right? Now, second question. Describe the distribution. Are there any obvious outliers? Well, I don't know. It says there may be, that one on the left may be one. So let's read what it says. It is symmetric. You guys agree with that? What else do you think about it? Unimodal. It has one mountain right there. And it's a bell shape, so it looks normally distributed, doesn't it? Okay. And the center is around what? 0.5. That's right. Okay. The values of p hat for the range fall mostly between 0.25 and 0.75, mostly. With the outliers, one might be an outlier at 0.15, and it stands out to us right over here. But we're not positive of it. We would have to like find that out, you know, like do some calculations and see if it really is. Okay, now C. Suppose your teacher prepares a bag with 200 chips and claims that half of them are red. A classmate takes a simple random sample of 20 chips. 17 of them are red. What would you conclude about your teacher's claim? Would you have reason to doubt? Would you question? Or would you just say, it's probably right?
Well, 20 out of 200 is very small, and so by chance, I mean, since half of them are red, I definitely think you could get 17 out of 20, and that could be red, because there's half of it is red. You get what I'm saying?
Yeah, it is no, I shouldn't say very. It is possible, isn't it?
Yeah.
Because if you did the whole sampling distribution, obviously, you're going to have some of them even be all red in the sampling distribution with every possibility. Now we have to think, is it likely, however?
Not really.
Probably not. So if you look back up here, in the 500 that they did, 17 would have given us a 0.85. And let me see if I can zoom in a little bit. That is not, well, let me focus. We're looking at this right here. I don't know if it, oh, look at there. Okay, so they had one at 0.8, so they got 16 one time. So they had none out of 500 that were 17, right? Let's take it back out so you're not looking real crazy. Okay. All right. So I would probably say, are you sure there's, you know, but it's not impossible, it's just improbable. Okay, now, I'm not wanting to read this whole thing to you because I don't want to bog down. We have a lot to cover, and I don't know if we'll get through it today, but some of these are my notes. Now, I think there may be a typo in this book because they called this the sampling distribution. What I would rather them have said that they would call this a sample distribution or a simulation of the sampling distribution. Okay, because the sampling distribution, as in the definition, involves all possible outcomes. These are not all the possible outcomes. Okay, now, so if we're looking at this, this is the population, and we need to go in a little bit so we can see it better. Okay, population distribution. I told you half of mine are red, half of them are not red. In their distribution, it was half are red, half are blue. Now, as you go over and do simple random samples, this person pulled one out, and this is their distribution of their specific sample. So they had 8 out of 20 were red, like Seth's were, so we could say that's Seth's. And here, 11 out of 20 were red, and here 13 out of 20 were red. So, and that was yours, right? 13 out of 20? Mm-hmm. Wow, we hit that one. That one's Seth's, that one's Dahana's. Cool. Okay, and then if you did many, this is after many sampling distributions, and so you're finding these proportions, right, and putting them on here. Okay, so the idea of a sampling distribution, the idea of it, take many samples from the sample population, collect the p-hats from the sample, so those proportions, and display the distribution of the p-hats. The dot plot shows the results of 500 samples. Okay, now, the reason why I'm making a big deal about that is because of this little bit right here, if we could see this. If you can see this. Terminology matters. Don't say sample distribution when you mean sampling distribution. You will lose credit on free response questions for misusing statistical terms. So be careful of that. Okay, is that focused? Just feels like it's not. I don't know. Okay, be careful. The population distribution and the distribution of sample data describe individuals. A sampling distribution describes how a statistic varies in many samples from the population. Okay. Let's look at this check your understanding right down here on page 420. Okay, let me see. Put it up just a little higher. Okay, so here we go. Mars Incorporated says that the mix of colors that they've got in M&M's milk chocolate candies is 24% of them are blue, 20% are orange, 16% green, 14% yellow, 13% red, and 13% brown. Now, that is their claim. That's what they're shooting for. Assume that the company's claim is true. We want to examine the proportion of orange M&Ms in the repeated random sample of 50 candies. Now let's talk about this. First, they're asking us to graph the population distribution. Identify the individuals, the variable, and the parameter of interest. So we'll look at the graph in just a minute. And when they ask you to make graphs, you need to make them neatly. It's not a freehand kind of deal. It is a, use a ruler or a straight edge or whatever. make it make sense to the reader. Okay, so let's talk about, what do you guys think to identify the individuals? What are the individuals in this distribution?
Like the M&Ms?
Yeah, they are the M&M milk chocolate candies. That's what we're talking about right here. Okay, now, what is the variable? What's varying from thing to thing? Color. That's right. Good. Okay.
Sorry,
Yes. Okay. Now, what's the next thing? Variable and the parameter of interest. What are we interested in about the color in this situation?
What percent are in each bag, I guess?
Well, what percent of what? Let's read back up here. We want to examine the proportion of orange M&Ms in the repeated random samples of 50 candies. Usually I bring in M&Ms and we do this, so we may need to do that next week when everybody's here. We'll try. Okay, good. Now let's look at the graph right over here, if I can get it. Whoa, it's crickety. I'll just move it over. Okay, so here is the graph. Here are the answers to the above, but they have blue, orange, green, yellow, red, and brown. You have color on the x-axis, the percent on the y-axis. See how nice and neat this is drawn? Now notice this is not a histogram. They are not touching one another. This is not like a time period. So this is categorical data right here, right? Not quantitative.